Now we are going to discuss the resemblances of lithium and magnesium. First resemblance, first resemblance, atomic radius. Lithium atomic radius is 1.34 angstrom units and magnesium 1.364 angstrom units, almost equal. Now I have just divided this into three columns. First one is property, second one is what it is for lithium and what is it for magnesium. So atomic radius, it is 1.34 angstrom unit, is 1.364 angstrom unit. Ionic radius for lithium plus it is 0.60 angstrom unit. For magnesium 2 plus 0.65 angstrom unit. Polarizing power, they are nearly equal for both the ions. Electronegativity for lithium it is 1.0, for magnesium it is 1.2, almost equal. Water decomposition, lithium decomposes water slowly and also magnesium also decomposes water slowly. Reaction with the bromine, they hardly react. They do not show any reaction. And also reaction with the nitrogen, both form nitrides. Other elements do not form nitrides. Lithium forms Li3N and also magnesium forms Mg3N2. Oxide for both monoxides are stable. Lithium monoxide and magnesium monoxide are stable. Solubility of hydroxides is very low in water. And also both hydroxides are very weak. Magnesium hydroxide is also weak and lithium hydroxide is also weak. And their salts are sparingly soluble. Their fluoride salts, phosphate salts, oxalate salts, and carbonate salts, lithium as well as magnesium, they are both are sparingly soluble. And the separation of hydrated crystals when a saturated solution is prepared, if you take a chlorides, magnesium chloride or lithium chloride, both will get crystallized out in the form of hydrated salts. And also both the chlorides are deliquescent. And also hydrolysis of chlorides take place in hot water. And also evolution of nitrogen dioxide and oxygen on heating. When you heat lithium nitrate and magnesium hydrate, a similar reaction is observed. And these are all because of the diagonal relationship with lithium and magnesium. Next one is extraction of lithium. See, lithium is a widely distributed compound, but its amount in the mineral is very less, and also extraction is not easy. Nowadays, the lithium is very much used in the lithium ion battery, which you are using for the cell phones. Even though lithium is found to be widely distributed, it is only distributed, it is not plentiful, but twice plentiful as lead in distribution. But if you take the amount in mineral, it is very less. And also extraction is not that much easy. Say, for example, the following are the minerals containing lithium: lepidolite or lithamica. The formula I have given, which contains 1.5% of lithium. Petalite, which contains 2.7 to 3.7% of lithium. Then spodumene, it also contains 4 to 6% of lithium. Then triphlite, which contains up to 4% lithium. And apart from this, certain spring waters or some plants like tobacco, beet, sugar can also contain lithium. You know, one thing, even our body requires a small amount of lithium. When a lithium is deficient, some psychological problems will come. You can see in the net what are all the deficiency disorders of lithium ions. First, it contains two parts of preparation, sorry, extraction. First part is the preparation of lithium chloride. Even the first part can be done in two different manners. First method is acid treating method, and the second method, fusion method. In first method, the mineral is finely powdered, then it is boiled with sulfuric acid. When you boil with the sulfuric acid, the silica and other insoluble substances, they will settle down, so they can be filtered off. Now the solution is taken, which is again boiled with the sodium carbonate, required amount of sodium carbonate, during which aluminium and iron will get precipitated. When you add excess of sodium carbonate after the precipitation of aluminium and iron, you are adding sodium carbonate in excess, then lithium carbonate will be settled. That lithium carbonate can be dissolved. Lithium carbonate can be dissolved using hydrochloric acid. Then lithium chloride is formed. You know, lithium chloride is soluble in alcohol, whereas other chlorides are insoluble, so can be extracted with alcohol. This is the first method of preparing lithium chloride. See, first stage is preparation of lithium chloride, in which there are two methods. The first method is this. In the second method, fusion method, the mineral is powdered and it is fused with the barium carbonate, barium sulfate, and potassium sulfate. Then it forms two layers. The first layer is alkali metals. The second layer is barium sulfate, aluminate, silicate will be settled down. Now the first layer is taken, which is washed and boiled with barium chloride. So barium sulfate will be settled down, and also the solution will contain sodium, potassium, lithium chlorides. Now you can dry it. Your dried powder will contain sodium chloride, potassium chloride, and lithium chloride. Now, if you add pyridine, pyridine will dissolve lithium chloride. So lithium chloride can be separated. Therefore, in these two manners, you can separate lithium chloride. Next, electrolysis of lithium chloride, the second stage. You are taking lithium chloride and potassium chloride. Why potassium chloride is taken? To increase the conductivity of the solution. So this conductivity, electrical conductivity, can be increased when you add potassium chloride. Normally the voltage applied in this electrolytic cell is 8 to 9 volt, and the temperature is maintained at 400 degrees centigrade. You can very easily look at the structure. The outer layer is brickwork. Outer layer is brickwork. Inner layer is a refractory lining. A refractory lining means which will just refract the heat content. And here is an iron covering, cast iron enclosure, cast iron enclosure. This is iron gauze. Gauze means where some porous material where the solution can simply enter in. And these are all graphite anodes. Anode is always a graphites. And what is in the middle is the steel cathode. And this solution is lithium chloride and potassium chloride, fused lithium chloride and potassium chloride. And here are two vents for the escaping of the chlorine gas. And what is floating here is the molten lithium. So when you pass the electricity, normally at anode, oxidation will take place. Oxidation means where there is increase in the oxidation state. See, the chlorine has the oxidation state -1. The chlorine has the oxidation state 0. So -1 to 0 is increase. So oxidation is taking place at the anode. At a cathode, reduction takes place. Reduction means decrease in the oxidation state. Lithium plus becomes lithium zero. So reduction. So what is here is the steel cathode where the reduction takes place. Once the reduction is over, all the lithium will float on the solution as a molten lithium, which can be extracted easily. So with this, we are completing our lesson.
Network problem ఉంది.
Okay, right.
Network problem ఉంది.
So all the best. Let us see in the next class.